3C, and I believe we're looking at cross sections. So here's a cross section. What? Did I do something wrong?
No.
I did something wrong. I
No.
said something weird.
No.
My
She's
beard
just-
is like
she's being
all
Leisha.
messed up.
No.
What's in your mouth?
It's fine.
You know I do find you entertaining. That's why I put you where you sit.
Oh yeah, you put her there?
That's why you're still allowed to be there.
That's why he keeps us around the front.
Yeah.
All right, so we have S, and I think we defined S as being, when we had to get this in terms of X, correct? Am I right on that?
Yeah.
Okay, and we said that X is equal to something. So when I squared both sides, what did I have up here, Ethan? Remember I had Y equals square root of X plus 3, correct?
Yeah.
So it'd give me Y squared minus 3.
Yeah.
And this would be Y equals X minus 3, and this would be Y plus 3 equals X, correct?
Yeah.
And then it's right minus left, am I right? Correct?
Yeah.
Okay. And then that will give me X plus 3 minus Y squared plus 3. I think I wrote this as a minus Y squared plus Y plus 6. Does that seem correct?
Yeah.
Okay, so this distance is this expression. All right, so I can say that S is a negative Y squared plus Y plus 6. And area is equal to 1/2 base times height, so it's S squared. And so in my integral, I'm going to have a 1/2 here. I'm going to take a negative Y squared plus Y plus 6. And I'm going to square it. And I think my limits were way down here to -2 and way up here to 3. So I went from -2 to 3. And I would put that one into a calculator because I would never want a student at this point to waste their time and try to square a cubic. And I believe I got 965 over 6. Pardon? Pardon?
Leisha, do you have a question?
You sure?
Yeah.
Did I write something wrong?
No.
Am I going too fast? Okay. Are you okay that I don't put this in the calculator? I think I showed you how to put it in the calculator yesterday. Okay. And that's approximately 160.833. All right, other side. Matthew, is there a mistake there?
Well, I don't know, I might just be doing something wrong, but I'm getting like, the answer's not close to that at all.
Answer's not close to that at all.
Yeah.
Okay, well,
Okay.
this won't be the first time I've made a mistake. I suppose, and so I got negative x squared plus x plus 6. Is that what you use, Matthew?
Oh, yeah.
Yeah.
I was confused about that too, I'm pretty sure just wrote it down, cause I was gonna ask him.
Okay, what are you gonna ask me?
Well, okay, yesterday,
Yeah?
you wrote down, for the 8 equals, it was like, Leisha, what was it? I don't have it written down.
It's 1/2 and then negative Y squared plus 2Y plus 9. But I don't know how we got
I
there.
it should be negative Y squared plus Y plus 6, which is what you wrote down this time.
Yeah, why did I write down 9 yesterday? That's crazy.
I don't know how we got there yesterday.
I don't think we were supposed to get there yesterday.
Well, now I gotta go back and talk about this one. this is correct, isn't it?
Yeah,
Yes.
I have here.
yes.
Yeah.
Okay, so this is okay, except, Matthew thinks my answer is wrong, right?
Yeah, I guess, yeah, I don't know, I'm not gonna.
Okay, that's fine, that's no big deal. So I'm gonna type this in again, a negative x squared, plus x plus 6, and everybody's in agreement with that, correct?
Yeah.
Okay, so I'm gonna come back here. I'm gonna have 0.5, my integral. I can go with the bars, that's what I'm gonna do. Y1, and I'm gonna square it. And this is 3, and that's a negative 2. And that looks correct. And I get 52.
Yeah, 52 as well. Same.
All right, so let me go back to here, since this was wrong yesterday.
No, it was just C that was wrong, wasn't it?
Yeah.
So I think we
Is
got it
fine.
all fixed now. I think
Yeah, except I was using that 9, so that makes me nervous.
You started using the 9 and C.
Because this is what I wrote. This is if I'm looking at my notes. I wrote y plus 3 minus y squared plus 3, and then I wrote down a negative y squared plus 2y, and I decided to take 3 times 3 rather than add the 3 and get 6.
Mine
Is there a 6 there?
yeah, but the 2y is just a y.
Did that look better?
Yeah, that's what I have.
Yeah, because also I wrote 2y, I don't know why I have that on there.
Maybe I just ignored the 2y for whatever reason.
Okay, and then, we had a rectangle, it was 3s this way and s this way.
Mhm.
So then it's gonna be 3 times negative 2 to 3 of a negative y squared plus y plus 6, that quantity squared dy,
Yes.
okay? So now I can come back to this
That'll do it.
and get rid of that 0.5 and put a 3 there. Oops. And I get 1,875 divided by 6.
Which is,
Which was 312.5.
I have 965 right
Yeah.
now.
Right, but that's using 2y plus 9.
Oh, so we did use it, but I didn't write it down. Interesting.
Yeah, so it's converted.
What? How did we do it wrong?
I am so
Well, I think what happened was I was just going off of my notes, and I had written my notes wrong, and that's what I had computed, and I didn't verify it with you, which is a big mistake. You should always verify it. And usually students are the best verifiers, because there's nothing more enjoyable, at least it wasn't for me as a student, to prove that the teacher was wrong. Okay? And actually, I really like it when a teacher proves me, or when the student proves me wrong. All right,
What happens when teachers?
what? That's happened a lot too. Yeah, I hate to say it, sometimes I think I write, I go up there and I said, oh, 2 times 2 is not 5. And that's what I use. All right, so we got the sum of 2 regions.
312.
And so I use this particular one, and there's a couple things I wanted to show you on this one. Some computer techniques. Again, this would be a calculator one. And I went to my graph. I'll get rid of this one. And I put in F first, I put in X minus 0.5. And then I put in X plus the sine of X. And if I look at my window, it looks like it goes from -1 to 5 maybe, and from -1 to 5 maybe. And oops, I'm gonna need more than 5. So let's go 6 and see how that looks. I'm gonna go 6.5. Oh, shoot, maybe I wanna get that intersection. I'm gonna go up a little bit. Yeah, perfect. All right, so, I'm not gonna guess, I'm gonna have my calculator actually figure out what those intersection points are. And the way I'm gonna do it on here, and I know you guys can do it on your on your TIs, I'm just gonna go say intersection. And you can see it's a -0.523598. And so I'm going to leave my menu, and I'm gonna come over here, and if I type in X, that's that value. So I'm gonna store that, and I believe on a TI it says STO, am I right?
Yep.
Am I correct on that? Okay. And so I'm gonna, here it's a right arrow, and I'm gonna put it into alpha A, which is directly below the alpha button. And if you notice, it repeats. So anytime I see alpha A, it's gonna have that value, okay? And the reason I'm gonna do that is I'm gonna go back to my menu, I'm gonna go back and graph it. And I wanna know what the other intersection point is. So again, I'm gonna go gsolve intersection. And so this is about 3.6 something, so there's a new X. And I'm gonna go back to my menu. And I'm gonna take that X, and I'm gonna go alpha B, which is just, it's log. Oops, I forgot my store. And so now that's stored. Everybody with me on that? And then I'm gonna do the same thing again. And get my third point, or my third ending, and that's around 5 point something. I get my stored in. And I'm gonna put that in alpha C. Okay? So, this is what you're allowed to do. And because I'm gonna have to have two integrals. Does everybody see that? Because the top and the bottom switch, that's the other part. So what I can do is I can say that A is equal to a -0.524, and I round to the nearest place. But I don't want to use that number. I want to use the numbers that I actually stored because it'll give me a more accurate answer. You don't want to round prior. You want to round it at the end. And so I'm going to say B is this. And I'm going to say C is this. Okay, so I rounded, and they will accept that. So now when I integrate, I'm going to integrate from A to B, and I'm going to have g of x minus f of x dx plus the other integral from B to C of f of x minus g of x dx. And so they'll see that the bounds are correct, or what they call the limits, and the integrants of each of these are correct. And so this may be worth 4 points. The answer's only worth 1. So you got 3 out of 4 just with this setup. Does that make sense to everybody? All right. So I'm gonna do that on my calculator. Then I'm gonna go to math, integral. What is the problem? Well, what the heck? It's like you're being stubborn. Okay, let's try it again. Well, I don't like that. Where's my button? Doesn't work. My 9 works. My delete button works. There we go. Oh, that's weird. All right, so I'm going to type in, go to bars, y2 minus y1. And here is I have alpha b. Here I have alpha a. I got plus. Go back to here. And I'm gonna have y1, so I gotta go to bars again. Minus y2. And we're gonna have alpha c. Alpha b. Did you come up with 4.511?
How do you do it on a PI?
Okay. You know I got an old PI, right?
Yeah.
Okay, what was it? X. And you have it in, you have no problem with this, right?
Yeah.
And, X plus the sine of X. And, make my window -1. Did I go 6 before? And I want -1. I think I went 6 above too, didn't I? Graph. There it is. So you have that, correct?
Yeah.
And you know how to figure out the intersections? Or no?
Yeah.
Okay, so you went second,
Yep.
and then you went over
Got
here
A, B, and C.
to 5, right? And that's, come over here, you gotta be on this side a little bit better. First curve, correct?
Yeah.
Second curve, correct? And so that's your X, correct?
Yeah.
And were you able to get it into,
Yeah.
okay, so you go back to math. There we go, X, store, alpha A.
Yeah.
Okay, and then you went back to your graph. And we'll do intersection again. Well, yeah. 5, but I gotta move this way. And you got that number?
Yeah.
I gotta get these in there, so. Alpha B. One more time. So you got that, right? And so you've waited a long time to get to this part, right?
Yeah.
All right, so you go to math.
Yeah.
And you come down to line 9, that's your integral. Yours probably looks like an integral.
No, I have what you have.
You have what I have.
Yeah.
So I'm gonna go over here, you have vars.
Yeah.
See that button? And you go to y variables. And they're a function. And do you see this listing?
Yeah.
Okay, you've been there before.
Yeah.
So I'm gonna type in y2 minus, I'm gonna go back to vars. Choose y1.
Yeah.
And then you gotta put, comma, then you gotta put an x, cause you're telling it to integrate with respect to x. And then you gotta put a comma, and then I gotta go alpha A, comma, alpha B. Parentheses. Plus, and then I'm gonna do it again. Now you go back to vars. You have y1 minus back to vars. y2, comma, x, comma, alpha b, comma, alpha c, parentheses. You see that any better? I don't know. You see that?
Yeah.
That's better, isn't it?
Yeah.
Yeah, hopefully we'll get the same answer. Might take a little while to think, 4.511.
Yeah.
Okay. Okay, now it says volumes, our base is the largest given region, which is this one right here. And it's perpendicular to the x-axis. So here's my S. And so my S, if I wrote it correctly, is g of x minus f of x. And it says, the cross sections are isosceles right triangles whose hypotenuse are perpendicular to the axes. So, in other words, my cross section looks like this. My S is down here. Well, I can never remember this geometry formula at all. But I know if I know these two numbers, it gives me the area, right? So area is equal to, so what I did is I called them x, is equal to x squared. Well, that's not very helpful because it needs to be in terms of s. But I also know that x squared plus x squared equals s squared, correct? So that means 2x squared is equal to s squared. So x squared is equal to 1/2 s squared. So in other words, a of x is equal to 1/2 s squared. Oh, I forgot something. Divided by 2. Right? Base times height divided by 2. So I gotta multiply that, divided by 2. Is everybody okay with that? So it's gonna be 1/4 of g of x minus f of x squared. So again, I'm gonna integrate from A to B. I have 1/4, I've already defined what A and B are, I've already defined what I already know what G of X and F of X are. And so I'm gonna come back to this calculator. And what I'm gonna do is delete all this. We'll put this in parentheses and square it. And multiply it by 1/4. Oops, error, what didn't you like? 2 decimal points, probably not a good thing. And so I got 1.11. Or you could just type it in like you did before, right? And so then this one is the smallest region and they're quarter circles. So I said S is equal to F of X minus G of X. So I draw my cross section. There's a quarter of a circle. I said this is S, so that's also my radius. And the area of a quarter of a circle is 1/4 pi r squared. Is that better? So I said A is equal to 1/4 pi s squared. So my integral is going to be pi over 4. This time from B to C of f of x minus g of x squared dx. I feel like I'm going really fast. I'm going really fast. Okay. So I'm going to come back up to here. I got a lot of zeros. I'm going to get rid of this first and we'll go parentheses, because I think I've had problems when I put this in without parentheses. I'm going to make that a 1. That's what's nice about Casio. I can do this, edit really nicely. Make that a 2. That's still going to be the same. Delete this. Make this alpha B. Delete this. Make this alpha C. And I got 0.213. Okay. So I'm going to make some changes. So tomorrow, I will talk about discs and washers. And then Friday will be a work day. And then Monday, I'm going to talk about arc length.